Hi everyone, today we are doing 2.2 function or not. So let's start with the notes. A function is a relation where each input matches to one output. So just like a vending machine, when you push the button C1 on the vending machine, only one thing pops out. If two different things come out or nothing comes out, then the machine is broken, not a function. So let's take a look at this one here. I'm going to split this page down the middle because the left-hand side are functions and the right-hand side is not. So the left-hand side here, on a table, this is a function because every single x value has one y value. 1 to 2, 2 to 4, 3 to 6, 4 to 8, 5 to 10, 6 to 12. Every single input has an output. So that's why it is a function. Here, this is not a function because if you take a look, 1 goes to 2, 2 goes to 4, and then 1 pops up again. 1 is going to 5. So that already is an error. There should only be one match. 1 goes to 2, so 1 cannot go to 5 again. So the error here is that the x repeats with a different y value. Okay? And then 3 goes to 8, 4 to 4, 5 to 10. So that was the only issue. That's why that is not a function. Let's scroll down and look at coordinates. This coordinate here, let's go ahead and label all of these coordinates. The first number are all the inputs. X is 5 here, x is 7, x is 9, x is 11. And then we have the y values as the second number. Y is 10, y is 12, y is 14. So this one is a function because, let's take a look. Every x value, so we have 3 goes to 6, 5 goes to 8, 7 goes to 10, 9 goes to 12, 11 goes to 14. No x values repeat. We're good. Let's look here. We have x, y, x, y, x, y, x, y, x, y. Let's look. 3 goes to 2, and then now 3 goes to 3 in this second coordinate. So that already makes it an error. Again, the x repeated with a different y value. This is why this is not a function. Not a function. Okay? Let's look at the next one. Here's a mapping, which is just like a table. So what this is saying is -2 goes to 4. 2 goes to 4. Now, some of you might be wondering, well, this isn't a function because it both maps to 4. Well, does every x have a matching y value? Yeah, -2 goes to 4. 2 goes to 4. 4 goes to 16, 5 goes to 25, 6 goes to 36. Y values can repeat. That's okay. That's okay. So this is a function. Now let's look here. Already we see that 9 is being mapped to -3 and it's being mapped to 3. So if I were to make a table, right, x, y, I have 9 here, -3, and then it says 9 again, and it's at 3. It repeats. The next one, we have 4 maps to -2, 4 maps to 2. These are all causing this to not be a function. It repeats. The 9 repeated with a different y value, the 4 repeated with a different y value. Again, x repeats with a different y. Okay, that's why it is not a function. And then the last example down here, let's keep splitting down the page. On a graph, we use a different strategy. We use something called the vertical line test. So for the vertical line test, what I'm going to do is I'm going to pass a vertical line across the graph, and as I pass it across the graph, let's see. Is it touching the graph only once every single time? So I'm passing a line, passing a line, passing a line. Imagine this line is traveling, right? If it was traveling in this direction, it only hits the graph once. Once here, hits it once here, once here, once here, once here. So it passes the vertical line test. This is VLT. Okay? Because it only hits, the line only hits the graph once as it's sliding across. Okay? So let's take a look at this one. If I'm sliding this one across, I'm sliding this line, already I see that it hits the graph once, twice. So it fails the vertical line test because it hits graph more than once. Okay? So our main annotations on the side here is that if x repeats with a different y value, then not a function. There we go.